And do you know when you guys are taking the BEC exam? Um, is it is it early June or do you guys know when you're taking the exam? Sorry, I couldn't hear you if you were speaking. I was just asking, when was the date for the BEC exam? Um, just curious. Oh, is it 11th of June?
Yeah.
Oh, okay. Okay, so we have around a month left before the exam. Um, so I will try to um cover a lot of things quickly. So, okay. Um,
We understand that.
okay, let's begin today by reviewing some of the materials that we studied before you guys had a break. Um, or we talked about what neutralization reaction is, and it is a chemical reaction, an acid and a base that forms salt and water. And here we also talked about element components. So if you were asked to name two elements that combine to form ammonia gas, you need to know ammonia is NH3, and the two elements that combine to form ammonia are nitrogen, over here the N, and hydrogen, which is the H. And we also talked about balancing chemical equations for specifically for formation of ammonia. And we can see um, nitrogen, sorry, nitrogen exists as a gas. So you need to know that it is N2. Same with hydrogen. Hydrogen gas is H2. It's not just H. But before we add the coefficients, we first have N2 plus H2 goes to NH3. But here, we talked about how this equation is not balanced. Um, so we will have to multiply either side by a number to make it equal. So since we have two nitrogen on the left and we only have one on the right, we can multiply this ammonia by two. Now we have two nitrogen, so nitrogen is done. Two on both sides. Hydrogen, there is six on the right side. You can see three multiplied by two, six. And we only have two on the left side. So if we multiply this by three, then we get six on the left and six on the right. This was the balancing chemical equation we learned last time. And moving on, we also talked about osmosis and diffusion. These are two ways particles can move. So osmosis is the movement of water molecules from less concentrated solution to a more concentrated solution through a semi-permeable membrane. So so concentrated means um, having how much solutes inside the solvent. So here, um, you guys can tell that the right side is more concentrated because it has more red dots. Those are the solutes. So osmosis will tell us that water will move to the right from a less concentrated to a more concentrated. So it'll result like this. An example is selective reabsorption in the kidney, where inside each nephron is inside the blood vessels, there are water absorbed and expelled. That's the formation of um, and and also water absorption by roots are occurring by osmosis as well. And here, diffusion is another method of movement of particles from high concentration to low concentration. So this is more about um, liquid and gas particles moving to spread evenly out. You can see from this picture, um, a sing a dye is dropped, a blue dye, and here it is very concentrated, but it spreads to other parts of the water where it is less concentrated. So eventually, it'll all be evenly spread out like this. More examples are gas exchange in the lungs. They occur by diffusion, water, and some nutrient absorption at intestine occur by diffusion, and spread of scent or even insecticides are caused by diffusion. If you spray an insecticide in your room, it eventually spreads to the rest of the room by diffusion. Because first, it is very concentrated, but it moves to a place where there are no insecticides, so eventually everything will be spread out.
Yeah.
Talk about some properties of metals and semi-metals as well, specifically focusing on these. Semi-metals are elements that have properties of both metals and non-metals. So silicon is a really important element that you need to know. It is widely used in manufacturing of electronic components, and all
Yeah.
of these semiconductors because they have both properties of metals and non-metals. They are very useful for these situations. Metals are hard, solid, are good conductors, and ductile. Painting, alloying, these are desiccator are all methods used to prevent iron from rusting. These are used, all three of these methods are used to make iron or metal stronger. So alloy is a mixture of two or more metals. You mix a metal and another metal, or a metal and a non-metal to make a certain metal stronger and more durable and more resistant to corrosion. Examples is brass, which is a combination of copper and zinc. We also have steel, which is iron plus carbon, and bronze, which is copper and tin. And we also talked about physical quantities and how they can be measured. So physical quantities can be expressed with numbers and units. These are, you can say, the properties of certain um, objects. So examples you would use is mass. You would measure the mass. You can measure it so it's a physical quantity. Same with volume. You can measure the volume of a certain object, and that is a physical quantity. You can measure the temperature, and you can measure the length as well, both of which can be measured and expressed by numbers and units. And SI units consists of base units and derived units, and those are basically units that are used for scientific measurements. You would use SI units to mark the mass, volume, temperature, length, and more. So basic SI units, some examples are kilograms, meter, ampere, and Kelvin. Derived SI units are something that maybe you combine multiple basic SI units to form a single one. So if you're finding a volume, you're combining multiple meters, it can be cubic meters, or for rates, can be meters per second. That is a combination of meter and second, basic SI units. There are many other derived SI units as well. The last thing I want to review was the hard water and the soft water. So be familiar with that. Hard water contains a lot of calcium and magnesium ions. So examples are seawater, well water, and groundwater, and even borehole waters. Um, and soft waters are um, ones that do not contain a lot of calcium and magnesium ions, such as rain or snow water, bottled water, distilled water. And um, you can use soft water. Using soft water can save soap. And boiling and adding washing soda are methods used to convert hard water into soft water. So if a question asks you, how can you convert hard water to soft water? You can say by first boiling or by adding washing soda. Those are two methods used to convert them. Those were all review, and we can get into some newer topics for today. So we'll begin with Newton's law. So let's first approach this problem. Says Hunter experiences a backward force upon firing a gun. Which of Newton's laws of motion is demonstrated in this situation? So in the picture, you guys don't need to be familiar with this quite yet. Um, but you can see from the picture, there is a action and a reaction force. So it's specifically talking about the backward force. So the answer will be the third law. And I will explain um, the first, second, and third law of Newton. So first law of Newton, first law is the law of inertia. An object at rest stays at rest, and an object in motion stays in motion at a constant velocity unless something forces it to change. For example, a book on a table stays there until you push it. So a book was already staying at rest, so it will stay at rest unless something acts upon it, like a force pushing the book down. Another example is a moving car keeps going unless you hit the brakes. So moving car is already at motion and it will stay in motion until you hit the brakes or eventually stop by friction. Another example is that if you're in a bus and it suddenly stops, you lean forward because your body wants to keep moving. So before, you were constantly moving, but when you suddenly stop, you still um, have the tendency to move forward. So that is why when you stop so suddenly, you would tend to lean forward. So an important takeaway is that object that is already at rest will stay at rest as it is, and objects in motion, things that are moving, will always be moving unless something forces it to change. You can see example pictures here. You can see a book just standing still because no force was applied. You can see the earth constantly moving around the sun because it's already in motion and no active force is going against it. So this object, the earth that is in motion, will stay in motion. That is also called inertia. This is a new vocabulary. Inertia is the property of matter by which an object at rest or in motion tends to remain in its state. And that's the thing that we've talked about so far. Rest will stay at rest, motion will stay at motion. That is called inertia. This bottom picture, we have talked about it before. A bus suddenly stopped, and since the people inside the bus were moving, they still want to move. They still have the tendency to move. But if they suddenly stop, their body will only move forward because bo because the bus suddenly stopped. And then before that, everyone was in motion. You can also see from the picture on the right too. She hit a skateboard on this box. The skateboard will suddenly stop. But since this person was before moving, she will just move forward. So that is the first law of. So Newton's second law is the law of acceleration. So the harder you push or pull something, the faster it moves. The more mass or heavier the object, the more force it needs to move. So this idea can be simply put in a formula, F equals ma, or force equals mass multiplied by acceleration. Acceleration is how fast an object's speed changes. So if you remember speed, speed is how fast the distance changes. So it's a change in distance. But acceleration is how fast that speed changes. But you can see from the formula, greater mass requires more force to achieve the acceleration. For example, to push a cart, more force is needed than an empty cart because the full cart has more mass, and more force results
Yes, you
in greater acceleration.
do.
So the harder you kick the ball, it makes the ball move faster. So this law explains why bigger objects or heavier objects need more force to move or stop. So you can see, it takes much more force for this person to push a ball that is 5 rather than 50 kilogram, which takes less force to achieve the same acceleration. The third law is the action and reaction. So for every action, it states that there is an equal and opposite reaction. This means when you push on something, it pushes back with the same force. Example is jumping off the boat. So you're pushing the boat backwards and you're moving forward. So there's this action and reaction. The action is moving forward, the reaction is pushing it backwards. The ball bouncing as the ball hits the ground, and the ground pushes it back up. In the example question before, we also had firing a gun. The action is the bullet pushed forward, and the reaction, the gun recoils backwards. So everything in motion has a reaction force, even if we don't notice it. So pushing off the ground over here is the action, and the reaction can be the ground pushing on you. There is always a reaction. And in this example, we talked about how the boat you're moving forward is the action, and the boat moving backward is a reaction. Same with pushing the wall. Pushing it is the action, the wall pushing it back is the reaction. So now let's get into force. So force is a pull or a push or a pull that changes an object's motion or shape. It is the capacity to do work. And we learned from Newton's second law that force can be calculated by mass times acceleration. And the unit is Newton, which is just N here. And force causes a lot of different types of movements. You can see magnetic forces, gravitational forces, frictional forces, um, applied forces, tension forces, and normal forces. All of those are examples of forces, which is um, the capacity to do work, or a push or a pull that changes the object's motion and shape. So let's quickly go back to this question now that we are more familiar with Newton's law. The hunter experiencing backward force upon firing a gun, so which Newton's law of motion is demonstrated in the situation. And now we can tell that the reaction and the action part was the third law. So this is Newton's third law of motion. And here is just an example question regarding force. So what force makes a ripe mango fall from a tree? Does anyone want to answer this question?
D.
I think I heard D, and that is right. It's the gravitational force. It's the force that pulls the objects down. Here, gravity or gravitational force um, is the force that pulls objects towards each other. And the more mass an object has, the stronger its gravity. So objects falling is an example. Planets orbiting the sun is another example. Walking on the ground, you're able to walk on the ground because of gravity. And the moon's gravity causes tides. And you can see a high tide and a low tide depending on the position of the moon, because the moon is pulling the water and the earth is pulling every one of us down to the center. That's why things fall and we stay on the ground. Now let's look at this next question. The force meter measures, does it measure mass, temperature, weight, or work? So on the right, this is an example of force meter. And what do you think these ones measure? I think I heard B, but it's not really temperature. Um, temperature is not really a type of force. Um, maybe
Tahu dah sah. Mak sains vedi oleh spesial. Cuma kasakan sains tu.
so. The answer would be C. It's the weight. And remember that weight is the type of force caused by gravity. So another way to put gravitational force in action is by weight. And weight is measured by mass times gravitational acceleration. So each planet basically has different gravitational acceleration. If you are on the moon, then you might have the moon has a weaker gravitational acceleration, so you would weigh less on the moon. The important note is just weight to the force. So if you're measuring weight, then you're measuring the force, especially the force caused by gravity.
Ayam.
Let's look at a theory question that was actually in 2024. It was last year. So the mass of a vehicle is 1,000 kilograms and travels at 100 meters per second. If the vehicle accelerates into 150 meters per second in 10 seconds, calculate the acceleration of the vehicle. So the first question is telling us to calculate the acceleration of the vehicle. We can do that by knowing the fact that acceleration is velocity change over time. So acceleration is velocity over time. Here, more exactly, it's actually the change of velocity over the change of time. So, for example, if you have velocity change, we started with 100 meters per second
Oh,
as velocity. Final velocity was 150. So the change would be 150 minus 100, which is 50. And the change in time was 10 seconds. So change in acceleration over change in time is 50 over 10, which equals 5 meters per second squared because it's acceleration. In the second question, it asks us to calculate the force that acts on the vehicle. So remember the equation, the F equals ma. To find the force, we just need to know mass and acceleration. We're given mass is 1,000 kilograms. So it's 1,000 times the acceleration, which we found here. 5 meters per second squared. And that, if you multiply 1,000 times 5 equals 5,000. And the unit is Newton. Or it's kilograms times meters per second squared. That is the unit for Newton. And the third question asks us to calculate the final momentum when the vehicle comes to a stop. So when the vehicle comes to a stop, velocity is just equal to 0. If it's just equal to 0, then to calculate the momentum, so actually the momentum is shown here. This is the equation of momentum. P, which is momentum, is equal to mv, which is mass times velocity. But since velocity is 0 when it comes to a stop, all you need to know is that the momentum is 0. You don't need to really know quite this formula, although you need to know F equals ma, that is important. But for momentum, know that it is conceptually more of like how you move. So when you come to a stop, you're not moving at all. So you would have 0 momentum. And that was this theory question. And is this clear for everyone? Um, did that make sense for everyone? Do you have any questions so far? Uh,
benim yani.
if you don't have any questions, it's fine. We can move on.
Yes, please.
You have a question? Yeah, feel free to ask.
Okay. I mean, I mean, it's not then.
Yeah, I wasn't sure if you were asking a question, but
David, let's go on.
okay, so we can move on to velocity and acceleration. So these are differences here because the test might ask you what is the difference or the connection between velocity and acceleration. And you can say that velocity is distance changed, which is also called displacement, over time. So it's change of distance over change in time. That is the velocity. But acceleration is the change in velocity. So it's a change in velocity over change in time. So it's how much velocity changes in a given time. Velocity is how much distance changes in a given time. So if you want to state the connection, you can say that acceleration, change in velocity, but velocity is the change in distance. So
Oh,
it's a really important concept that you need to know.
Okay.
And if you're asked to calculate the velocity from here to here, the distance is 30 meters. And it takes him 5 seconds to get from the start to the end of this 30-meter track. Then you might ask, what is the velocity the man is moving, or the average velocity? Then it's going to be 30 meters over 5 seconds because it's change in distance over change in time. 30 divided by 5 is 6, and we have 6 meters per second. If you're asked to calculate the acceleration, for example, here, the car is moving at a speed of 30 meters per second. So we are given the velocity. Velocity is 30 meters per second here, 35 meters per second here. To find the change in velocity, you subtract 35 minus 30, which is 5. And how many seconds have passed? It's 10 seconds. It's after 10 seconds. That's going to be 5 over 10, and it's going to be meters per second over second. This will be equal to 0.5 meters per second squared, because this second moves down. That is how you can calculate both velocity and acceleration. Now we are getting into the concept of work. So to begin this topic, let's start by a question. So the work done by the force of 20 Newton on a body is 60 joules. Calculate the distance through which the force moved. Is it A, 8 meters, B, 4 meters, C, 3 meters, or D, 2 meters? Work is basically force times distance. So here, work is 60 joules. And force is 20 joules. So you're calculating this, the distance. So 60 divided by 20 should equal 3, right? 3 meters. So it'll be C. So if you said C, then that is correct. Now let's talk more about work. So work is done when a force moves an object in the direction of the force. So that's why work is calculated by force times distance. It's basically how much distance you covered by the force. That is the work you have done. And the unit, remember, is the joule. An example is lifting a box. Work is done because force is applied upwards. You're lifting a box and you apply the force upwards and the box moves up. So we can say a work is done here. Pushing a wall, on the other hand, there's no work done because the wall doesn't move. Remember, work depends on force, the amount of force you push it, but also the distance covered. And that's why work happens when force moves an object. It changes the distance applied by the force. This is the connection between work and force. So here, a man pushes this 20 Newton force, pushes the box with 20 newtons of force, and the box is moved 2 meters. The question might ask, what is the work done here? The work is force times distance, 10 times 2, and 20. And the unit is joules. The work is joule. On this side here, this man is pushing it back and this man is pushing it forward, but the box doesn't move. Even though force was applied, force might be a number, but the distance is 0. It doesn't move. If it doesn't move, work is also 0. There is no work done. Is everything clear so far? Did anyone understand? Yeah, okay,
Yes. Now. Yes, please.
yeah, that's good.
Yes.
Then let's solve this question. So a machine lifts a load of 100 Newton through a vertical distance of 2 meters in 10 seconds. What is the work done by the machine? Can anyone answer this question? So I think I heard C, and that is correct because work is force times distance. Force applied is 100 newtons. Distance is 2 meters, is 100 times 2, which is 200 joules. That is correct. Let's look at theory question about work. So the first question really asks, what is work? And how will you answer that? Well, work, you can answer that by saying work is done when force is applied and the object moves. So
Okay.
if you want to define work, always state how the force, when the force is applied and the object moves. Always write these two things when you're defining work. What is work? Work is done when force is applied and the object moves. You can also write work equals force times distance. Second question. A block of wood of mass 100 kilograms was dragged through a distance of 3.2 meters when a force of 20 newtons was applied. It asks you to calculate the work done. We have force of 20 newtons, distance of 3.2 meters. It's the same as the last question. It's simply multiplying 20 F multiplied by D, the distance, 3.2. If you put it in calculator or you can do it in your head, it becomes 20 times 3.2. And if you calculate that, it'll be 64 joules. And always remember the units. Force is newtons. This is force. Distance is in meters. Work is in joules. So always keep your units in the theory questions. Okay, so now we're ready to move on to another important topic, which I think this will be the last topic for today, which is potential energy. This is also very important. So a pupil of mass 70 kilogram climbed a building of height 15 meters. Determine the pupil's potential energy at the top of the building. So this question is asking us to calculate the potential energy. And potential energy is given by this formula. This is important. Maybe it's good for you to memorize. Potential energy equals mass times gravity times height. So potential energy equals mgh. That's how you put it. Mass, gravity times height. And here, mass is given to be 70 kilograms. Gravity, which is just the gravity of the Earth, which is 10 meters per second squared. That is the gravity. And then we're given the height, which is 15 meters. Simply, it is 70 times 10 times 15. And if you put it in a calculator or if you can solve it on paper, the answer you will get is A. It's 10,500 joules. That is the amount of potential energy, and it's measured in joules, you can see. Yeah, this is a similar question of determining potential energy. Can you guys solve this question? So it's determine the potential energy of a block of mass 2 kilograms placed on a building 10 meters tall.
The answer is D.
Yes, that is right. The answer is D. Because mass is 2 kilograms. The gravity is given to be 10 meters per second squared. That is the typical gravity that we experience on Earth. So you can assume that it is 10, and height is 10 meters, and you multiply everything, and you get 200. Look at this theory question. So figure 4 over here on the right is an illustration of body of mass 20 kilograms placed on top of a wall with height of 10 meters. Calculate the potential energy of the body. And you can do it by, as we have done before, 20 times 10, 20 kilograms times 10 meters times the gravity, which is also 10, and you will get 2,000 joules.
2,000. This is 2,000.
So you can actually formulate this potential energy from the equation of the work. So potential to do work is the definition of potential energy. So if you have the formula of work, which remember was force times distance, was the work. But force is also given by the weight. Remember the weight? Weight was mass times gravitational constant. Remember, if your ball is falling down by gravitational force, then that is the force applied because gravity pulling it down. That's the force. Force equals the weight. Weight is m times g. And distance over here in the work equation is also the height. If we replace all this, it becomes mgh equals the potential energy. So potential energy is the ability to do work. It's a potential to do work. That is how work and potential energy can be connected. So actually, I'll go a little bit more, maybe until the power. So just to finish this area of force and everything, let's quickly talk about pressure too. So just pressures are just a different way force can be used. So if a cuboid of a weight, 100 Newton, remember weight equals force, and it has sides 5 centimeter by 10 centimeter, calculate the area of the cuboid, which is simply 5 times 10, 50 cubic centimeters. That's the area. And the pressure exerted by the cuboid when it lies on its side. When it lies on its side, the pressure exerted is given to be force over area. We have force over area. We have force of 100 newtons, because always remember weight equals force, because it's the gravitational force. And divide that by area, which we found to be 50 centimeter cubic centimeter, centimeter squared. And you get 2 newtons per centimeter squared. And this is the pressure, this force over area. Again, this is something that maybe you need to get familiar with. You can think of on the right, force being applied per area. You can think of force per area is the pressure.
Yeah.
I'm not sure if they will give you a formula sheet in the BECE test, but if there are no formula sheets, then you just have to remember that pressure is force over area. But this is not as important as the other one. Like the important ones. Yeah. Is do you have anything you want to say, or if you don't, always just note that the important formulas is F equals MA is an important one, and work equals force times distance is another one. And you can also, this is another important one, um, mgh, which also equals the potential energy. So these are really the important ones that you need to know for the test.
It continuously rotated and revolved precisely. No, yeah. That was it. That was my decided.
So last thing I want to cover is power. So let's answer this question. A
50.
machine lifts a load of 100 newtons through a vertical distance of in 10 seconds. What is the power of the machine? So power work over time. So
It's up. It's up.
It's actually given by work overtime. So work here can be calculated. Remember,
It's B.
Hey,
work equals, yes, that's right. But if you explain it, then
what's the B?
done by force times the
No, you
distance.
with you.
Force 100 is the force.
Alright.
Two
It's
means
B.
distance.
I
You
can't
see,
tell.
So the work done is
you times this
200
one and divide by 10.
work.
Yes. B. C. 100
Yeah.
times 2.
Uh,
Equal to. So
Mama say
this
A.
one divided by 10.
so it is
You get it.
200 over 10 seconds. This is time. Remember, power equals work over time. We found work to be 200 by force times distance, and power is 200 divided by 10, which is time over here given. And we get 20, so it is B.
Yes, I did.
That is
Really?
right. And yeah, power, talking about power, watt is the unit of power, and it measures how fast energy is used or transferred. Because it's divided by time, it's per second. Per second always means how fast is it doing. So this is work per time. It is how much work, how fast work is done, how fast energy is used. Another way you can measure power is by voltage times current. That's just another way to find the power. But here we just learned about work divided by time. That is the definition. So you can interpret when you see a label that says 100 watt of light bulb, you can now tell that the light bulb uses 100 joules of energy per second. That's what 100 watts mean. It uses 100 joules of energy every second. It's how fast it drains your energy. And we have this last theory question. Um, Defining the term power. Again, the important thing here is the rate. You make sure to state the rate at which work is done. That is the definition of power. The rate at which work is done. Work done over time or voltage times current. Second question, if a machine hauls a packing case of mass of 50 kilograms up in a building that is 10 meters high in 30 seconds, calculate the power of the machine. So this can be a little tricky, but you can do this by calculating the work done and dividing it by time. Remember, work equals force times distance. So work is 500 times distance, 10 meters, we have 5,000 joules. Since it moves in 30 seconds, it's 5,000 joules over 30 seconds. And that's going to be equal to the power. I hope this makes sense for everyone.
Yes.
This
Yes.
will, yeah, the end of today's lesson. Um,
Yes.
have any questions so far? Are there any questions you want to ask me?